Let's take a look at some one-step equation word problems. And this is just going to be kind of an upgraded version of one-step equations because you've got to turn the word problem into an equation first in order to be able to solve it. But the actual equation and the actual solving will be just like the previous lessons that we've been working on. So number 1 says the smoothie shop offers a free smoothie each time a customer earns 100 points on their rewards card. If Kennedy needs 28 more points, how many points does she currently have on her card? So I'm going to let C equal the current number of points, and then use C to come up with an equation. So she currently has C points, and if she gets 28 more points, then she's going to have 100 points total on her card. Now, a lot of you can probably read that equation and know, not the equation, the word problem, and know that all you have to do is 100 minus 28, and that gives you the answer. And that's a great skill to know and be able to recognize, but it is also great to be able to write an equation that represents the word problem. So we have that here with C plus 28 equals 100, and then to solve that, you would need to do the same thing to both sides, which would be to undo the plus 28 with minus 28. And if you subtract 28 to both sides, and you'll have a calculator, so double check yourself, C is going to equal 72. So she currently has 72 points on her card, and then when she gets her extra 28, she'll have 100 points total. Number 2 says an online photo storage site offers a payment plan where users can pay for a year membership in 12 equal payments. If Morgan paid $8.25 per month, how much did he pay in full for the year? So let's how about Y equal what he paid in a year. And we know that he had 12 equal payments, and each of those payments was $8.25. So a couple of different things you could do for an equation here. You could say that if he made a total of 12 payments, and each of those payments was $8.25, then $8.25 multiplied by 12 should give you the total cost for the year. So there's one way you could do it. Another way is to say that if Y represents all the money in a year, then Y divided by 12 would have to equal $8.25. That's another way to do it. And a third way to do it, you could say that since each payment was $8.25, then the total amount in payments divided by $8.25 would have to equal 12. So that's 3 different ways you could model that one. Ultimately, you just need to know what math you have to do. So for the first way we wrote it, we would need to multiply 12 times $8.25. For the way in green right here, you would multiply both sides by 12, and you would still be doing $8.25 times 12. And then on this way in dark pink down here, you would multiply both sides by $8.25. And so I hope you can see that regardless of how you set this one up, the math that you've got to do is 12 times $8.25. And you'll have a calculator. And that's going to give you $99. Comes out evenly. So $99 for the year. Okay, number 3, Valerie bought a new car in 2015. 1 year later, the car had depreciated, and depreciated means it's losing value. So the car's not worth as much as it was when she bought it. That's pretty standard. Once you buy a new car and drive it off the lot, it instantly loses a little bit of value. But it depreciated by $3,400, and now it's worth $26,280. Find the value when she purchased in 2015. So I'll let P equal the purchase value. And there's several ways you can set this one up. We could start with P and say that the purchase value minus $3,400 is equal to $26,280. The other way to do that one that might make sense to you is that if it's now worth $26,280, then if you put the $3,400 back on there, then you would get the amount that it was worth when she purchased it. So there's 2 good ways to model number 3. On the bottom way, you can see that all you have to do is add those 2 amounts together. And on the top, you would need the inverse operation, and you would add $3,400 to each side. And you've got your calculator, so 26,280 plus 3,400 is a total of $29,680. Okay, number 4, if a candlestick burns at a rate of 0.6 inches per hour, how many hours will it take an 18-inch candle to burn? So we'll let H be the number of hours, and it's burning at a rate of 0.6 inches per hour. So how many hours will it take an 18-inch candle to burn? So if we know it's going to be H hours total, and for each of those it's going to burn 0.6 inches, then you can set this up by saying 0.6 times H is going to have the whole candle burn, and it's an 18-inch candle. So it's 0.6 times H equals 18. And when you put a number and a letter side by side, it means that you're multiplying. So 0.6H equals 18 is a slightly better way to write that. And then to solve this, you would divide both sides by 0.6. And you're going to get a value that's more than 18. If you do 18 divided by 0.6, you're going to get 18 divided by 0.6, I did 0.06. You're going to get 30 hours. And that does make sense, because if it's burning less than an inch per hour, then it's going to take more than 18 hours to burn 18 inches. It should be about twice 18, which is 36, because it's burning about half an inch, but it's 0.6 of an inch. So it does make sense that it takes more hours than inches of the candle, because you're burning less than an inch each hour. So I hope that makes sense. So that one is 30. Okay, so rewatch this if you need to. Go back through and be super duper sure you know how to do all these, and that will help you on your quiz. Best of luck.